And now moving to hypothesis testing, really everything else you're going to do is going to be based on hypothesis testing. Any kind of test, anytime you want to answer a research question, is going to come down to hypothesis testing. So really pay attention to the concepts discussed in this particular part also. So let's take a look at some basics of hypothesis testing. In statistics and research, we're always testing for, associations, relationships, and connections. Now, these statements, much like when we talked about making conclusions in terms of the population, your hypothesis questions, right, your hypothesis, they're always, so there's a reason why it's bolded here and capitalized, is because this is a really important lecture here. These statements are always about the population and never about the sample, right? This goes back to the idea of saying that you don't ever have to make an estimate of your sample, right? What do you calculate from that sample when you get a p-hat, when you get an x-bar from a sample? That's exactly what that number represents about your sample. You don't need to make a guess about it because that's the truth about the sample. And you have to remember your objective in statistics is really to say, well, I calculated this mean value, this x-bar from my sample, and I hope that this is very close to what the population is telling me. I hope that this value I've estimated in my work is really close to the truth, right? When we say population, we're thinking about the truth, Mother Nature, what really goes on. So your hypotheses are always a statement about the population, which means that when you write your null and alternative hypothesis, these are always going to be about your parameter and never about your statistics. So let's look at some basic steps of hypothesis testing. So these are the steps you're going to use for the rest of the semester anytime you want to make a test. You want to answer a research question you have, these are the steps to take. So first thing is you obviously want to have your research question. What is it that you're interested in? What is something you want to answer? Is it about if you believe that using this drug or using this intervention will truly help people to quit smoking or really help people reduce their calorie consumption? These are going to be your research questions. So you want to determine, you want to write it in a way that's standardized so across all researchers, anyone looking at your work will understand what your scientific question is. So we really want to start with folks, so that's why it's a little square here, is because we want to focus on how do you write this null and alternative hypothesis, and then after that we'll look at which of the two models to go with and what test to use. So the overview of testing, and you can see here, the idea with null and alternative hypothesis, again, I'm emphasizing over and over to you that these are statements about the population, right? Because every semester I still get a lot of students giving me the null and alternative hypothesis in terms of a sample, in terms of statistics, but we never want to write that in your statement. So let's start with the null hypothesis here, with H naught here. This is a statement of equality. Okay, so you can think of this as a statement of equality that's really saying that nothing is really happening. It's status quo, no difference, no effect. So you're saying group 1 is equal to group 2. You're saying the control group is equivalent to the intervention group. Versus now you have the alternative hypothesis. Now this is where your research theory applies. This is where you make a prediction to say, I believe that group 1 is going to outperform group 2. Or simply that there is a difference between the two groups. So you always have about 3 directions for alternative hypothesis. You can see here, you can say, well, group 1 is going to perform better than group 2. Or you can say group 1 is not going to, group 2 is going to perform better. Or you can say group 1 is simply different from group 2. So your alternative hypothesis would really be one of the 3 directions you see here. So here's a quick slide to again show you that the null hypothesis, right, null meaning nothing and H naught, right, so this is a 0, it's a statement of equality, right? We're saying the mean blood pressure, if I have a new drug and versus an older drug, maybe you have a different formula, I'm saying that in my null hypothesis, if this drug is believed to help with blood pressure, I'm saying it's not different. status quo, there's no difference, nothing is really happening. Notice also that in my expression here, right, these are parameters, right? This is population mean and not X bar. So that's really for you, really, really important. I want to I'm saying it over and over again to really drive this point that these are statements about the population. So even when you express it in words, I'm looking for keywords about the population. So here's another learning check for you to kind of stop, pause, and see if you're understanding what we're talking about so far. So which of the following is an example of H naught? Right, so take a second to see if you can get the right answer here. Right, so the answer here is D. But before you even look at the question, now this is something about breastfeeding, but even if I didn't read the context of the question, I know right away there are two things I can eliminate right off the bat, right? And which one am I talking about? You can eliminate A, right, and C, because this is about X bar. It's about your sample, right? You never talk about your sample in your statements, your hypothesis statement. And you can actually already eliminate B because why? Because there's a direction here, right? This must be HA then, and not H naught. So of course these hypotheses come in little pairs, right? You have H naught and HA. So here's where we've talked about earlier. HA, your alternative hypothesis, is really where you get to this is what you are interested in. This is where you get to say, I really believe that my intervention, my drug program is going to help these people. Right, so this is where you get really excited about your work and you can pick one of the three directions that really makes sense to you down here. Right, you can say, well, maybe blood pressure in A is going to be greater than B, or it's going to be less than B, or that. They're just not equal. So versus the null statement was a statement of equality, now it's a statement of inequality. So the logic of hypothesis testing is really I want you to parallel this idea to the American jury trial. Right? We always believe that the defendant come in what? Innocent until they are proven guilty. So really want to parallel that idea to hypothesis testing is that we always start by saying that I believe the null hypothesis is true. Everything you do in statistics, you're going to assume the null hypothesis is true. Right? You can assume the defendant is innocent. And then we get data, or you go out and collect data yourself, right? That data is your evidence. Maybe if you're thinking of a jury trial, you can have a witness, you can have video evidence, you can have some other evidence that comes in to say, if this evidence is true, if this video is true, right, this video surveillance or this witness is telling me the truth, I have evidence to say that the defendant is not innocent, is guilty. Right, so that idea is the same in hypothesis testing in that you assume the null hypothesis is true, right? You assume a statement of equality, and then you have data that comes in, and that's your evidence to tell you which of the two models to go with. Do you go with the null hypothesis, or is that null hypothesis invalid because of your new evidence? If evidence tells you there is no way the null hypothesis is true, then you would reject that idea. Right? So that's really what we do in statistics too. So when you're deciding between the two, should I go with the null hypothesis, should I not go with the null hypothesis? You have that data, right? So you need to do something with that data you have to tell you which model to go with. Is it likely that the null hypothesis is true? Is it unlikely the null hypothesis is true? So to do that, you need to calculate a test statistic, which is kind of a data summary of it helps you summarize your data, which then gives you an idea of which of the two models to go with. So a test statistic, you can see the little structure here, but it'll make more sense when we look at it in another example. But you want to, so once you have your data, you have your evidence, you want to be able to calculate the appropriate test statistic, which will then give you a probability of getting what you get given that the null hypothesis is true. In other words, the test statistics will help you pump out a p-value, and that p-value will help you decide, make an educated guess of saying, there is no way the null hypothesis can be true given this evidence we have. So in this lecture, because we're calculating for a population mean, we are going to use a z test statistic, and you can see the structure here is your estimate minus some hypothesized value of interest divided by the standard deviation.